Welcome to Complexity Made Simple. My name is Paul Allen, and before we get into today's video, well, I'm just going to remind you the 3 books that are on sale. Drink tea and read the paper. If you're a green belt and a black belt and you want simple instruction on how to apply your skill, design of experiments for 21st century engineers, and finally, a statistical process control for small batch production. They are all available from lulu.com and the links are in the video below. Welcome to Complexity Made Simple. My name is Paul Allen and the subject of today's video newsletter, well, we're going to answer a question that's been sent in by a viewer. So Frank W, I said last week I would answer your question. If whenever you watch any of my videos, if there's a subject that I haven't covered or a more detailed question you would like to ask, I am more than happy to answer those questions. So please leave your comments in the area below or subscribe to see all the videos in the channel. Now Frank's question is quite long. If you wish to see the whole text, you can see it on a comments page. It's on a video called Observed versus Inferential Statistics Part 2. So if you want to take a look at the whole question, please do. But what I've done in order to help us out today, I've paraphrased the questions. There were 3 elements to it, and here are the 3 elements. Let's take a look. So here we go. Here's the 3 questions that Frank has posed to me. So he talks in his comments about senior managers and engineers not being on the same page. So when an engineer is trying to fix a problem, a senior manager is trying to cut cost. And of course, you can't fix the problem without extra cost. And engineers just fight with senior management, so they're not being consistent. So could we use some statistics in some way to help us to get senior managers and engineers on the same page? How do we stop operators fiddling with process parameters and taking the process away from proper settings? And could there be some automated way to compensate for noise in a process? A little bit like noise cancelling software, which works brilliantly, by the way. So 3 very good questions. So I'm going to answer these questions one at a time. So Frank, I'm going to do my best on this. So here we go. Let's try and answer them one at a time. So question 1, first of all, we want to get engineers and senior management kind of working together, not pulling in opposite directions. Yeah, so okay, is there a way to do that? Now for me, Frank, the answer here lies in design for Six Sigma. So really the reason why engineers and senior managers pull in different directions is because they don't really understand what the customer wants and what the customer values, and they haven't agreed what the customer wants and what the customer values. Because if they'd agreed that, then they would understand that what they're doing has to be done. So the thing in Design for Six Sigma that helps to pull everything together is a prioritized voice of the customer. And this is the key thing, the fact that it's prioritized, not just a list of things that the customer wants. So it needs to be prioritized. Now obviously one of the things that will be in that list undoubtedly will be the cost of the product. So there'll be a list of, is it safe, is it reliable, is it very strong, can I drop it on the floor and it survive, that type of thing. Does it cost me 30 quid or less? So there'll be lots of things. Cost will be one of those things. But if you've got a prioritized list, then you understand how to make a proper decision. Otherwise, you just fight one another. And that's really what happens. The engineer wants to solve the technical problem. The manager wants to keep the cost down, wants to make more money. So if you've got a prioritized list, and let's say the strength of something. So, you know, the customer has decided that the product needs to be robust, and therefore strength of a plastic moulding is very important. And that's because robustness to the customer is very high on the list. And if it's higher than cost, yeah, so if they're saying, well, the fact that the product can be dropped on the floor and it just bounces is more important than what I pay for it. And if you look at things, I mean, look at an iPhone, for instance. We pay £1,000 for an iPhone. It's just a bloody phone, for Christ's sake, and yet we're prepared to pay the extra money. Why? Because it has other things that are worth £1,000, so we're prepared to pay. So if you say the strength, the robustness is important, then when an engineer says, well, I need to make the mouldings, I need to make the mouldings thicker, therefore, of course, I'm going to use more material and I'm going to add cost in order to do that. Well, if that requirement is above cost in the prioritized list, no decision to be made. Anybody can make the decision. Don't even need a senior manager to make that decision. And that's what's needed, because customers don't buy. It's rare that customers buy anything based on cost. You know, petrol we buy on cost. We'll buy flour on cost. You know, things that are standard products we will buy on cost. But if you think about a car, I could easily knock £1,000 off the price of a car. It would be dead easy. I could take all 4 doors off. And people will say, well, that's ridiculous. No, it's not, because if you go back 100 years, cars didn't have doors. That was something that initially they didn't want. They just wanted the fact that it was a motorised carriage, and they were perfectly happy with that. But now the idea of saving money by taking doors off a car is ridiculous, because we know the prioritised voice of the customer. Customer wouldn't buy it. Customer will pay £30,000 for Christ's sake for a car that in 1900 they were paying £800 for. So times have changed enormously, but part of it is there's an implicit understanding of the voice of the customer. So that's the key thing. You have to have a prioritised voice of the customer in the design process, then all decisions can be easily made. There is the answer to question 1. Question 2 then, what we got here. How to stop the operator fiddling with process parameters. Now, I think you also mentioned that if we've got engineers and senior managers on the right page, and that they understand certain things on the machine is important in order to please the customer, how do we make sure that the operator doesn't go fiddling with things? Okay, so question 2. We want to stop operator fiddling with parameters. Okay. Now there's a couple of things here. There is a tool that you can use, and you probably know which tool I'm going to mention. But the first thing is this. Why don't you just define the operator's role and responsibility? Because this is one of the main ways to do this. The first thing to say, look, what's the role and responsibility of management? What's the role and responsibility of operators? The role and responsibility of management is to set good rules, whatever that means. So that could be a cleaning routine, it could be speeds, feeds, temperatures, the way a machine is run, maintenance routines. We do this maintenance once a week, once a month, once a year. Purchasing policies. We always buy from the best supplier, we always buy from the cheapest supplier, we always play suppliers off against one another, whatever they happen to be. The management Their role is to set good rules, all right? And world-class companies would tell you what those good rules are. Then the role of the operator, whoever they are, by the way, whether it's somebody in the purchasing department, somebody in the planning department, somebody in the manufacturing department, what is the operator's role and responsibility? Dead simple. Follow the rules. That's it. This is what world-class companies do. What world-class companies do is make great rules, then they make sure everybody follows them. End of story. What we don't want is us to set no rules here. And for the operator, who we pay the cheapest salary to in the whole company, for the operator to try and dig us out of the hole that's being created because the processes won't work properly. Why would you expect the cheapest paid, least trained person to be able to save you money? That's ridiculous. They are just going to drive your process into the ground if you've set no rules. But you set good rules, and then the role and the responsibility is for the operator to follow them. And by the way, it's also for the management to follow them. So if somebody says and comes to you and say, what would you like me to do, Mr. Manager? Violate the rules or not get the job out on time? You stick to the rules. You always stick to the rules. That's the end of it. That's our senior manager's role and responsibility. When I worked for Sony, one of the great things about working for Sony, we had rules, and the senior managers always stuck by the rules. So that's job number one. So that's, you just set the policies and procedures, set the roles and responsibilities properly. But answer number two here, so that's one. Answer number two is to give the operator some training and to train them in statistical process control. Because what statistical process control tells them to do, of course, it tells them when adjustment might be necessary. Because sometimes it is. But without SPC, without understanding the difference between signal and noise in a process, an operator's toast at this point. What an operator will typically do, they say, without this tool, an operator, 90% of the time, what do? They will make your process worse because you cannot be bothered to give them a simple graph and a pencil and a piece of paper and teach them how to use it. If you did that, your operators could help you to run your processes better. So the answer to number two, how do you stop the operators fiddling, get them on the same page as the engineers and the senior managers? Well, clearly, first of all, if they've got prioritised voice to customer, then the rules are made really well. Then you tell the operators that you got to follow it. Now all of this, they all talk to one another. That's the way this thing is supposed to work. Okay, and what's the last question? Could there be some automated way to compensate for noise in a process like noise cancelling software? Which is a fantastic idea. So question three, noise cancelling, some kind of automated noise cancelling system. And what he's asking me is, have I ever seen it? Do I know for a system? And unfortunately, Frank, I know that you work in the world of electronics, I think, where noise cancelling is possible. I wish it was possible, but it isn't. And the reason it isn't is because in the world of electronics, there's a couple of things going on with noise cancelling. In an electronic system, so you are listening to your MP3 player and you've got noise cancelling software on it. The system knows that there is a line coming in that carries the noise and there is a line that carries the signal. So in other words, the signal in an MP3 player, of course, is the music that you are listening to, and it knows what the signal is. Anything else that's coming into that system, it knows where it's noise, and of course it can listen for noise externally to the MP3 player. So you've got the music, and then you've got the external sounds and therefore the system knows what the noise is. So that's one big difference. Now, in a manufacturing process, when I make this piece and I'm looking at the size of the piece, the dimension that I get is made up of both the signal and the noise, and I have no way of knowing which bit's which. Can't measure it, therefore I can't cancel the bit of noise out. Okay, so that's the first problem. But there's another problem, and it's the speed at which the information is available. Electronic systems are reacting like that, especially with extra processing power and the speed of processors and things like that. So the response to the noise is almost instantaneous. Well, it has to be instantaneous with noise cancelling, because the sine wave is obviously the opposite of the noise signal that's coming in. So it's an instantaneous response to a known wave of noise. Number one, we don't know the noise in manufacturing, and number two, the response is not instantaneous, because this is what happens. I make this one, maybe this one took 30 seconds in the molding machine to manufacture it. I then measure it, and by the way, I don't know which bit's signal and which bit's noise at this point. But then there's another 30 seconds till this one comes out. Where do you cancel the noise from? Where's the point where I have to inject some kind of electronic correction so that this one is okay? The response time is always different. The cycle time for making these might be different to the cycle time for making this plastic body, etc. So it's so complex to try and put noise cancelling. You wouldn't know where to put it. The response is so slow, so it's a very discrete, because it's a very discrete result, So where'd you put the signal to cancel out the noise? But also, there is no way of understanding how much of what I've got there is signal and how much is noise, and therefore you can't just offset it with some simple sine wave, because we can't measure the sine wave. So unfortunately, it's a great idea. I know we sometimes talk in some of my workshops about, I wish we'd had a dial on a machine that could adjust the noise down, but we don't. Noise cancellation in processes just comes from this. Typically, noise cancellation in processes comes from setting good rules and adhering to them, because you get this. It's very straightforward. You get your money making process. So we're going to make some money here. I've got inputs coming in. I've got an output, maybe two outputs, maybe three outputs coming out. I'm trying to please the customer at this side. How do you noise cancel in a manufacturing system? Well, it's very simple. You just cancel the bloody incoming noise. So that's what the set of good rules do. So if you have a temperature, you make sure that the temperature is fixed to 100. If you have a speed, you might make sure that the speed is fixed to 32. If you have a pressure, the pressure might be 131 psi. And what you do is you make sure those are fixed, never moved, never adjusted. You stop the operator putting unnecessary noise in. If you've got material, how do you get rid of the noise in the material? Well, you make sure that you buy from good suppliers. In other words, you're not buying on price. If you just buy on price and you let that material come in and it's very noisy, you just get noise coming out the other end, and you violate the tolerances and you produce lots of scrap and cost yourself lots of money. So noise cancelling in a manufacturing process comes from these. And then these people adhere to those rules, noise goes away, And you don't need anything complicated. You just need good rules. That's what the best companies do. So there are your 3 questions. Frank, I hope I've answered them as well as I possibly can. If there's anything else, if there's something I've missed out or I've misunderstood, please drop me a line. If anybody else wants to ask me some questions and say, hey, how do you do this? Have you seen this? Has your experience ever found a solution to this? Please send me a message. Please leave some comments in the area below. It helps with the channel. Please subscribe. Don't forget that you can get a copy of my ebook, Drink Tea and Read the Paper, if you'd like to get more thoughts on lots of different things in process improvement, Six Sigma, etc. And if you drop me a line, I hope to hear from you soon. But guys, come on. Get your processes under control. Get the noise out of your processes. And if you do that, what will your process do? It will just make more money. Thanks for your questions, Frank. Good luck.